couple more properties of waves. Waves reflect. What do I mean by that? Well, for example, light waves reflect off of a mirror. We had already talked about this concept here, that a string wave, which is traveling down a string, will reflect off the wall, off of where it's fixed, and that string wave will go back. And yeah, friction makes it eventually die out, but it'll go in both directions because it'll reflect off the wall. And sound waves reflect off of surfaces. So waves will reflect, and waves superimpose. So what does that mean? That actually has to do with interference. But waves superimpose, meaning that if I have one wave and I have another wave and they're on top of each other, they interfere. And that's actually just called the general term is superimposing, so that they will add or subtract, right? Whoops, that was supposed to be a larger wave, constructively, or something in between. So that just means that waves add if they overlap, like we already talked about with constructive and destructive interference. That also means that if we've got a string wave, let's say, that going down a string, and I start it going in one direction and it bounces back in the other direction, now we've got two waves. We've got waves going in both directions, and they will superimpose, and so we can, depending on the speed of the wave in the string and the frequency of the wave, we can get some interesting patterns, which we will explore later. But this concept of superimposing you need to understand. The reflection, in order for the string wave to superimpose upon itself, it's got to reflect off the end. And so what that means is if we set up the right situation, we can get what's called a standing wave. So these arrows here, I'll come back to standing wave. These arrows here are supposed to indicate that the wave is traveling at some velocity. That means that, let's forget the fact that it bounces back for now. Let's not let it bounce back yet. And let's create a wave. At one instant in time, the wave looks like what I've shown here. And at a later instant in time, what it means by the wave is moving over, what the wave speed is to the right, the wave velocity is to the right, is that wave has moved over somewhat. So now it's moved over, and we have maybe created some more wave. That was not a terribly well drawn. Yeah, that's all right. That's all right. So what the peak that was there is now there, right? Because it has moved over some distance delta x. So I just tried to draw that a little better here. I don't think it's really any better, but the idea that the wave is moving to the right means simply that the peaks move over. So this peak has moved over to there, and this peak has moved over to there, etc., that the peaks move over. That's what it means by moving. Hopefully that was clear. In order to see waves actually moving, we'll run a simulation. I'm just trying to do still images, which is a little bit difficult. But what I wanted to get at was the concept of what's called a standing wave. Because we've got, let's say that we're driving a wave on a string. Driving it, meaning maybe we're oscillating it up and down at this wall. And so we're driving a wave on the string. As it gets to the other end, it bounces back, and so now we've got two waves. It's as if we're creating a wave at the other wall. We've got a wave going to the right and a wave going to the left, and they will at any instant be superimposed on top of each other, and what that results in, and we'll see it when we do a simulation, is sometimes it can result in complete, depending on how we do it, it could result in pretty much destructive interference. It could result in seeing a wave that actually moves, just a more complicated wave that is moving, or it can result in what's called, so that would be nothing, or just a regular continuous wave, or it can result in what's called a standing wave. And a standing wave, you have probably seen before in physics lab, looks something like that, and the standing wave doesn't move or doesn't look like it's moving because the wave that's moving to the right and the wave that's moving to the left are adding just right so that you've always got destructive interference at these points and you've always got constructive interference at these points. The red points are called nodes, and the green points are called antinodes. And I will show you examples of that when we get to the wave simulator. But nodes and antinodes. That's a standing wave. Now what I'm showing here, which you can't see because nothing's moving, is that in the picture on the bottom, the wave isn't moving anywhere. You don't see the wave moving anywhere. All you see you always see a maximum here or here and here, 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 and here, here, and here, here, and here. But those bumps don't move to the left or the right. They don't do that. Okay, that's a standing wave. So that's just some properties of waves. Right? The fact that waves, what a wave is a disturbance, the fact that it reflects, the fact that it superimposes, that you can have longitudinal and transverse waves, and that you can have continuous waves, pulses, and standing waves. So next time, we're going to start with writing down the wave equations of a wave and looking a little closer at the physics.